Good morning everyone. Today's lecture topic is Introduction to Toxicology, Occupational and Environmental. So toxicology is the science that will study the effect of the chemical agents on humans and other animals, and usually toxicologists are measuring the exposure to the humans from the chemicals and drugs and some hazards as well. So the hazards can be divided to different types. So there are occupational toxicology and environmental toxicology. Occupational toxicology studies the chemicals in the workspace. Like here we can see the manufacture of the metal gold manufacture. So and this man has a protection of the airways and also a cloth to protect from the poisonous metals, and the goal of the occupational toxicology is prevent the absorption of the chemicals that can lead to the diseases. And also occupational toxicology will regulate the minimum amounts of the allowed exposure for the toxins, and will guide the manufacturers to include the preventive measures for the to decrease the exposure for the workers, so to prevent the chronic diseases. And usually they work in collaboration with the governmental organizations that may differ from one country to another country, and there are also some voluntary organizations that may recommend some measures to increase the safety of the work and to release some guidelines for that. Also, the environmental toxicology we studied on botany is dealing with the chemicals of the environment and also pollutants like air pollution, water pollution, and soil pollution. All of these usually are a result of the human intervention. Like air pollution is mostly from the factories and energy plants. The water pollution is from chemicals like polycarbonated, bisphenols, and others. We will dig in detail for that later. And soil pollution also comes from the garbage that you throw away every day without the separation. So when you throw your garbage, it's better to separate the plastic and recyclable items and non-recyclable items to different bins. Um, um, and there is also ecotoxicology that is concerned with the effect of the chemicals uh, to the pollution of the communities within ecosystems. So we studied ecosystems on biology as well. So uh, and ecotoxicology is studying the transfer of the pollutants between these ecosystems. Um, and um, interaction between these ecosystems uh, and the opposite to the traditional toxicology, ecotoxicology is not concerned about the specific organism, like for example human. It's concerned about the ecosystem, so that includes not only living organisms but also non-living organisms, like non-living items like air, soil, and um, water. So okay, then let's talk about the some terms and terminology and definitions. So first terms are hazards and risks, and the hazard is something that has the potential to harm you. For example, you are lying on the beach taking a sunbath and you see a shark in the sea, but you know that there is no way this shark can um, can go to the beach and eat you unless you go to the water. So at that time the shark is a hazard for you. So but uh, if you will uh, enter the sea and swim, then uh, and if you uh, enter the sea, then the hazard becomes risk, and risk is the frequency of occurrence of uh, some exposure of the physical or chemical agent. And there is some probability that the uh, shark will eat you. So you have uh, a real danger that about your life. So that is why you should not enter the sea with the sharks. So that is a risk now. So so if you can calculate the uh, probability of some hazard, then that is a risk. So but if there is zero probability, then this is just hazard. And also there are many routes of exposure. The most commonly seen routes are oral, airways, and skin contact. So on the oral is by the food, through chemicals in the water and food. Then the uh, inhalation is the most commonly seen route of entry because it's easy to have chemical dissolved in the air and evaporated to the air. And the last one, transdermal, is um, not so common, but also can be seen in some industries. Then duration can be acute. So acute is one-time exposure that leads to some damage, and like for example poison, uh, and if there is a multiple exposures longer than several days, then it is a chronic exposure, uh, like for example smoking, uh, and sometimes the exposures that are chronic can become acute if, for example, uh, the, there is a sudden release of a large amount of the chemicals, and can lead to the death. Okay, and then let's talk about the environmental considerations. Um, and there are some um, chemicals that are imported for the environmental uh, environmental safety. Um, and these chemicals like polychlorinated biphenyls, so this is one phenyl, this is second, and there may be any amount of the chlorine on any position here, 1 2 3 4 5 6, and organofluorine pesticides that are commonly used uh, for the food in the crops, um, and these are mostly lipophilic substances, uh, and they bioaccumulate in the body fat, and can be stored in the tissues for a long time, and they can be released over time and may lead to the chronic adverse effects. And if these chemicals are incorporated into food chain, then biomagnification can occur. So biomagnification is a way by which the um, concentration of the chemical can increase because all the organisms in the food chain will be contaminated. So, for example, this is a phytoplankton that is eaten by a small fish, and then so this zooplankton eaten by the small fish is increasing the uh, intoxication of the small fish. So now we have a double the concentration of the polychlorinated bisphenol in this fish, small fish, then is eaten by the larger fish, and then triples the concentration. Then, sorry, it's 4 times now because this is multiplication, and then this large fish eaten by the apex predators like for example the whales, killer whale, uh, and this ends up with the highest concentration due to biomagnification. So uh, in like previous century, they hunted for these whales to obtain an oil for candles. So after the invention of the electricity, this is not more case, but still this leads to the bio accumulation, and that is why the whales may die from the intoxication. And then there is also a biomagnification that leads to the increase in the concentration within time as the fish will grow up. For those fish that will live long, and for those toxins that can accumulate in the body, like for example mercury, is building up through the years, and if someone will eat this fish, then he or she can be poisoned. So that is why when you go to the restaurant, ask to prepare a fish from a small and young fish, not with the large and old fish. Usually the large fish is old fish, so prefer a small fish. Okay, so then let's go through the primary air pollutants. So that include to the particle matters that are coming mostly from the rubber, from the vehicle rubber that is produced when the vehicle will stop stop in accidentally, like the emergency during emergency, and also during the normal driving. Uh, the part of the rubber is uh, goes to the air with the small rubber particles that are dangerous for the lungs. Then sulfur dioxide is also a very potent colorless gas that is irritant um, and usually produced by combustion of fossil fuels. Uh, then the it usually irritates the eyes and mucous membranes and skin, usually absorbed by the lungs, and leads to the bronchoconstriction, and uh, that increases the airflow resistance and can lead to the uh, uh, asthma. Uh, then nitrogen oxide and nitrogen dioxide. These are also, nitrogen dioxide is irritant as well. It's brownish, uh, unlike the sulfur dioxide that is colorless. Um, and usually associated with the fires, and also is produced from fresh silage, those smell that you can feel from the silage. That is why farmers are mostly exposed to the nitrogen dioxide um, contamination, and that is called Silla village disease. The nitrous dioxide is irritant and leads to the pulmonary edema and can lead to the cell damage as well, uh, and also irritating for eyes and nose. Uh, Usually 1 hour is enough to produce a pulmonary edema, and also can higher concentrations can lead to the death. Oh, then ammonia. Uh, Ammonia is commonly used in the uh, also in the agriculture, and in some chemicals, also released in some chemical plants. So this is also mostly occupational toxicology, and also is irritant and absorbed by the airways, and also the skin, through the skin, can be absorbed through the skin. So after the exposure, the skin should be washed uh, with a mild soap and flushed with the water. Then volatile organic compounds. So this um, uh, uh, group of the chemicals that uh, includes many volatile gases, um, and that's maybe the solvents that include halogenated aliphatic hydrocarbons, and mostly in cleaning agents. Uh, that includes many chemicals, uh, and they are carcinogenic, and uh, that is why it's recommended not to avoid these substances. Uh, uh, so that can be seen in the dry cleaning uh, stores, and also freons that can be found in the refrigerators, also uh, like in the air conditioner and refrigerators. Um, Also, these hot compounds can be found in the drinking water as well. There is no specific uh, um, treatment for these toxins. And then methane is a commonly seen uh, air pollutant. Um, and Methane is particularly uh, dangerous in the production, in the plants and facilities where it's produced in large amounts. Um, and usually can also be seen uh, in some villages that use methane for cooking, for uh, in the for the as a source of the fire in the kitchen, for the stove. Um, uh, Usually the so this is not occupational but environmental toxicology. Uh, so that exposure is from the if the stove is uh, so if stove is not equipped with the automatic uh, detection of the fire, so and if the water is overfilled and will uh, stop the fire from the burning, and then the gas will eventually go to the atmosphere and to the living room, so that can lead to the death as well, and also the source of the fires and exposures as well. So that is why it's recommended to use only in a good ventilated environments, and also the window should be open during the switching the stove on. Then secondary air pollutants, these are formed in the air by oxidation and reactions between the previous pollutants. That includes ozone. Ozone is formed from the oxidation, and secondary particle matter will form by degradation of the primary particle matters. So then there is a threshold limit values, TLVs, for common air pollutants. For example, for the carbon monoxide is only 25 ppm particle per meter. So if also for the so this is like commonly seen in fires, during the fires, and can lead to the death as well. So uh, for the other gases, like for example the lowest is ozone, what is less commonly seen. So nitrogen dioxide is also 3 only. Okay, then so for the carbon monoxide has a uh, high affinity to the hemoglobin than oxygen, and that is why it's so toxic. Even 1.1% of carbon monoxide will lead to the 50% saturation, and that leads to the headaches, nausea, vomiting, and further breathlessness, collapse, and loss of consciousness and death. So common sources are house fires, car exhausts. For example, if car is in garage and doors are closed, then the exhaust can enter the cabin of the car and the driver can lose consciousness and die. Then boilers and furnaces, if they are not connected to the air vent correctly, and cigarette smoke for secondary smokers that are around those people that are smoking the cigarettes. So that is why we here at the Kazan State Medical University are prohibiting smoking cigarettes because of the carbon monoxide toxicity, not because we don't like the cigarette smokers, but That is why I ask you, please don't smoke around the university where most of the students are coming out from the entrance. So if you want to smoke, go find some place where no one is uh, going by, so you don't contaminate the and intoxicate the children, elderly people, and other pregnant women for the carbon monoxide toxicity. Oh, and for the treatment of the carbon monoxide, there is a specific barocamera is required, and the patient is concealed under the high pressure, like 2-3 atmospheres pressure of the uh, oxygen pressure. Oxygen is given under the pressure to treat this disease. This equipment is not available in any hospital in our city. That is why treatment is very limited. So thank you for your attention for today and see you next week. Bye bye. Doha,
Will
will
you
you
attend
attend
the
the
class?
class today?
Yes,
Yes, at which time?
I think it,
Which?
I think 11.
What is your time? What is your clinical pharmacology class today?
11, I think.
Actually, for group number
I don't
three,
know.
we don't have classes in Friday anymore. We finished them
Doha,
on
why you
Friday.
are answered yes if you don't have class today?
No.
You even don't remember where is your clinical pharmacology class. Okay, so anyone is from group number 3 or 4?
No, that's all. That's
No,
all
that's all.
for
Okay.
group three. That's all.
Good, then see you next week or today at 3 p.m. group number 4, please.
All
Yes,
right.
please. Um, I think Sirin will attend and Isa maybe also. I hope so. Okay, bye bye.
Goodbye. Goodbye.
Goodbye.